Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. Today on the podcast, we are joined by Mark Brady, who is a world-class expert in data management. Dr. Mark Brady is currently the Deputy Chief Data Officer for the Office of the Undersecretary of Defense Test Resource Management Center and Senior Manager at KBR. He has served as the Chief Data Officer for the Space Force, Chief Data Officer for the Air Force Space Command, Data Architect for the Department of Justice, and Information Architect for the National Marine Fisheries Services. He's also helped establish electronic trade standards as U.S. delegate to the United Nations. He served on the White House Data Cabinet and the National Oceanic and Atmospheric Administration's Big Data Council. Prior to his federal service, he conducted basic scientific research in neuroscience, taught neuroscience and statistics, conducted industrial R&D in artificial intelligence, software, medical electronics, traffic management, and a whole bunch of other things. He's the author and inventor with a number of patents in the industry. We're super excited to have you on. Welcome to the show today, Mark.
Hey, Jaden. Good to be here.
Really excited to have you on. Like I mentioned, the first thing I wanted to kick this off with was just asking you a little bit about your journey. Like, what brought you to this industry and where you are today? Did you always know you were interested in data and AI and tech and all this kind of stuff? Like, tell us a little bit about your journey. Have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app, or go to spotify.com/podcasters to get started on your podcast today.
A Netflix original film.
The Wi-Fi isn't working.
In the event of a global communications breakdown, do the following. Stay inside.
What just happened here is happening everywhere.
Avoid strangers.
We've all been deserted.
I don't trust them.
And most importantly, do not panic. Julia Roberts.
What happens next?
Mahershala Ali.
I knew something was coming.
Leave the World Behind. Rated R. Now playing only on Netflix.
Well, I've always been interested in AI before there even was AI, and got involved in neuroscience as a way to leverage new ideas and so forth in the field when I was working in industrial research and development. And I fell into data management just almost by accident. Started working for National Marine Fisheries Service, doing natural resource management, and found that I had a knack for it. And there was a whole lot of demand for that area. And so that's where I got into the government service and found it to be very easy, even though it seems very mysterious to a lot of folks. So.
Yeah, that's such a fascinating background. I really I honestly, I think that's very unique. I don't hear a lot of people that started in like neuroscience and make their way to AI. It's oftentimes like a lot of like just more super into like math or even computer science and kind of finding their way in. So that's kind of an interesting segue, but it is interesting. That's like, you're the second person I've recently had on that started in the fisheries, in the United States Fisheries Department. Then recently I had someone, they were working on computer vision to essentially, before they would catch a bunch of fish, kill them all, and then to check if there was endangered species. Killing the endangered species is kind of ironic. And so, of course, they invented a computer vision thing that could just kind of go through and count without having to kill the fish. But super fascinating. So walk us through, what, I guess, you've been interested in this for a long time. Mm-hmm. What kind of made the push into this field? What was, I guess, the big step or the aha moment? You got started in the fisheries department, and was that the first place?
Well, no. I did AI research when I was working for a 3M company and worked for a Kodak holding part of that, and was doing AI primarily in computer vision. So the Kodak work was in electrophoresis. So you've got these electrophoresis gels, and they may have thousands of different spots on them after you break down the proteins and DNA, RNA, and so forth. And it takes a long time for humans to process all that. So I developed an algorithm that could do as well as a human, but do it much faster. And then after that, I started working with 3M did a lot of different things for 3M, but one of the things was in computer vision for traffic management. So in traffic management, one of the main objectives is to determine whether there's a breakdown or an accident so that you can get emergency vehicles out there right away. And they don't like to cut into the pavement to put in electromagnetic sensors. So the idea was to create a computer vision system to do that. So we did that, and then I got a call from the government division in 3M, and they said, "Hey, we've got this biometrics thing, and it's kind of floundering because we can't get the algorithm to recognize the fingerprints to work right." So then I adapted the traffic algorithms to biometrics in just a few days, and then within less than 2 weeks, we had a working algorithm.
That's incredible. That's fascinating. So you've obviously been working in this space and doing some really incredible things for a while. Something I would love to kind of pick your brain about. I know you have this kind of background in neuroscience that a lot of people don't have. What I would love to ask you is, how would you define AI within the larger realm of intelligence?
Yeah, so that's an interesting question because right now there's such an interest in AI, almost a renaissance, that everyone wants to get on the bandwagon. There's a lot of marketing and everything that's called AI, even though it might not be AI. And so we have to kind of go back to the basics and understand, well, what even is it, right? And, what is intelligence? So I find that you really can't draw any dividing line between intelligent information processing and any other kind of information processing. So it's really all intelligence. And the only distinctions are in terms of autonomy. How autonomous are those algorithms, whether they're in your brain or in a computer? And if you look at Turing's definition, for instance, the Turing test, which most people who've studied this are very familiar with, it's really an imitation test. And I don't think that that's at the heart of AI. AI is not about imitation so much as it is about autonomy. And if you think about what are all the things that the human brain does, right? It breaks down into various categories such as motor outputs. Language is one of those, a special case. So you could kind of consider that separately to an extent, and perception. So all of these things are what make up intelligence. And then artificial intelligence is just those processes that have been considered until recently unique to humans. And so what's interesting about that, I think, is that it makes it a moving target. So things that we've done in the past, which absolutely amazed humanity in terms of innovations and inventions, now are not considered to be very impressive at all. And so it's always, what is AI is always changing. It's a frontier.
Yeah. I think that's so true. And it's such an interesting topic to define. As you mentioned, it really does feel like we're having kind of this renaissance for it. Something that I've heard you mention before, and I would love for you to explain a little bit on the podcast, is the concept of extra intelligence. And, if you could tell everyone why, what it is, the concept about it, and, why it was previously unnamed.
Yeah. So, we just defined artificial intelligence, and there's intelligence which is uniquely human, which we're always trying to press against with our advances of artificial intelligence. But then going out the other way are those capabilities that computers have that humans do not have. And it's one of the things to note about that is that humans are not likely to acquire that. Whereas machine intelligence is always increasing, human intelligence is either static or it's decreasing. And, so what do computers, is this something in the future? No, not really. It's something that already exists. And if you think about the first ENIAC or even a mechanical calculator, they can compute faster and more accurately, reliably, both in terms of calculations and logic, than humans can. So there's always been extra intelligence, and it's going to be this vast, expanding realm of capabilities that we really can't even conceive of at this time.
Yeah, I think it's so interesting, but I also think like making these definitions is important. As you mentioned, like the industry, there's kind of like this whole buzz in there right now. But I think, having these definitions defined really helps us understand like how far the technology goes. Something I would love to ask you about is, in what ways do human and machine intelligence like differ from each other?
Yeah, so understanding this is going to be key to advancing AI. So traditionally, computers have very concrete memory. You put something in there, it could be random digits, characters, whatever. It can remember that just as well as it can remember things that are meaningful. Humans are very different in that respect. It's difficult for us to remember something unless it has some meaning. And the way that we gain that meaning, we appreciate that meaning, is by taking new information and hanging it in a framework of what we already know. And psychologists, going back to James many years ago, called this associative learning, associative memory, which is something that until recently, we could talk about that a little bit too, machines have not had. The other connection there is that the associative learning is represented at the neural level. It's something called Hebbian learning. So if two neurons have a synaptic connection to each other, that synapse is often strengthened when those two neurons are firing at the same time. So all the way from the psychological level down to the neural level, you see this associative learning. So what does this do for us? What capabilities does it give humans that computers have not had? And that is the ability to do analogical reasoning, right? So in analogical reasoning, we start to see the relationships between areas that are not obviously connected. And that, if you think about education, human education, I would say that's really the definition of an educated person. Not that they have a paper degree, but they took whatever it was that they learned at the university, high school, whatever, and then adapted it into other areas, which seem to be possibly unrelated. So as an example, you can think of Newton and his studies of the celestial world, and he really developed his laws of physics there where you didn't have complications like friction and so forth, and then brought them down to Earth. Now, looking back at that, we think, well, yeah, sure, it's all the same physics. But at that time, the celestial realm and the earthly realm were considered to be two very distinct things. And so, and even though obviously Newton was a genius, humans use analogical reasoning all the time to do things that computers can't easily do.
Okay, and you were mentioning at the beginning of this a little bit about how this was just up until recently that computers didn't have this ability. Right. So tell us about what happened, the shift.
Well, I had this theory, and I think it still holds to some extent, that in order to get to the second singularity, what most people call the singularity, you have to be able to have that ability to do analogical reasoning. And that has to start somewhere, right? You can't just have an analogy built on, an analogy. You have to start somewhere, which would be the physical world, right? But then along comes Chat GPT, and everyone was wondering, are we on the cusp now of the singularity? So I started playing around with it, doing experiments to see if it could perform analogical reasoning. And lo and behold, I am seeing elements of analogical reasoning in GPT. And I think the reason why it's able to do that, if you look at the way that transformer neural networks work, they are looking at interrelationships within the input of different words, as well as the interrelationships between the input words and the output that it's generating. And I think that may be the basis of some analogical reasoning, although this isn't going to bring us to the singularity in terms of perception, computer vision, or robotics. In those cases, you're still going to need to have a connection to the real physical world.
Mm-hmm. And would you be able to just, for people listening, would you be able to just describe briefly about the first singularity, maybe describe the previously unrecognized first singularity and discuss some ways maybe we could potentially reverse it?
Sure. So the only thing that's really been spoken about very much is the singularity, or what I'm calling the second singularity now.
Yeah.
And one of the defining features of that singularity is a loss of control over technology. So I started thinking about that a little bit more, and I realized we can lose control of technology without there even being AI. And in fact, we are. And one of the reasons for that, there's two reasons. One is a general lack of literacy in the area of describing our technology. We're kind of in a post-literate era. Sure, we write a lot about different things. A lot of it's trivial. But when it comes to documenting our technology, we don't really do it. And so then when you're building the next version or something, or integrating different technologies together, or even a user trying to use a product, they have to essentially reverse engineer it. And then, or somebody does it for them sometimes, and then they publish on that esteemed journal known as YouTube. And that's how we find out about it, right? But this is very inefficient. And if you look at some of the quality of what we're producing in terms of software, there's some excellent product out there, and then there's a lot that really is very poor. And so it is having a major impact. It's not hard to find bugs plus design flaws. It takes me about 5 minutes to find design flaws just looking in any direction, and there's really no reason for it. You think after all this time that we've had to develop design principles for, say, a user interface, that everyone would know what they were and that they were following them. The other reason for the first singularity, this loss of control over our technology, is the level of need for technical talent, always expanding. Things are becoming more automated all the time. This requires more talent. And there's an idea that, well, we need to train people. Okay, here's a backhoe operator. We're going to make him a computer programmer or whatever. And that could happen. But it's not going to happen generally, because only about 4% of the population goes into engineering and computer science within a particular age group. So we have a talent shortage, and you're starting to see that companies are competing with each other much more intensely now for that technical talent, and we're just not going to be able to create it. So how do we get around this? Well, first of all, we have to care about quality. We have to start doing that, and we have to start documenting what it is that we're developing. And the second thing is, and this is where AI comes into the first singularity, we can use AI as a way out of the first singularity. If you look at developing software, for instance, you've got a design phase, which is usually skipped entirely by most teams these days, which is a problem. And, then there's the development phase, the test phase. So how can AI participate in all this? Well, we know that.
This episode is brought to you by Shopify. That's the sound of switching your business to Shopify, the global commerce platform that supercharges your selling. Harness the best converting checkout and same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Stop leaving sales on the table. Discover why millions trust Shopify to build, grow, and run their business. Sign up today for your $1 per month trial period at shopify.com/tech23.
This episode is brought to you by Klaviyo, the platform that powers smarter digital relationships. With Klaviyo, you can activate all your customer data in real time, connect seamlessly with your customers across all channels, guide your marketing strategy with AI-powered insights, recommendations, and automated assistance, Deliver experiences that feel individually designed at scale and grow your business faster. Power smarter digital relationships with Klaviyo. Learn more at klaviyo.com/Spotify. That's KLAVIYO.com/Spotify.
AI can generate computer code. We're starting to see that already, and that it's only going to get better. In terms of design, the design documentation can be assisted using AI because many times the reasoning is, well, we just don't have time, which isn't a very good reason. But anyway, that's something that could be overcome. And I think the most interesting one would be in testing, which is a field that I'm working in right now, actually. So testing, you have to run software through its various states, of which there could be many, maybe even an infinite number of states. And secondly, then you have to recognize when it's in a state, if that's a bug state or a failed state. So humans can do the second very well right now, computers not as well, and computers dominate in the first. So a computer could take a piece of software through orders of magnitude more states than a human could. And if it could also recognize which of those states was a bug state, then you would have software which was much more reliable and bug-free. Right now, what do? As part of First Singularity, we wait until we fall into one of these states. Then oftentimes you call up tech support. The person doesn't know, right? Anything about it. The engineer is long gone. He's doing something different. And they say, well, turn it off and turn it back on. Why did that actually works off? Why? Because you're coming out of the bug state, you're entering back in, and almost at random, you either do or don't fall back into another failed state. So that's why being able to probe all these states before releasing software would help us to get out.
Okay. That makes a lot of sense. And I think a lot of people, well, I don't know. There's definitely people that aren't doing that, but a lot of people would agree with you that that's what's important. Something I would love to ask you about, right? You mentioned a bit about the second singularity and people's questions about ChatGPT. How do you kind of, what do you envision as the path to the second singularity? And what is ChatGPT's role in that journey?
Yeah, so as I was saying earlier, I have a hypothesis that having experience in the physical world is going to be a prerequisite to getting to the second singularity. And I modified that a little bit after my experiments with chat. And like I said, I think it's still going to be essential in terms of perception and in terms of learning motor. But what's going to get us there is going to be, at least for areas of AI, is going to be experience in the physical world, which will mean robotics. So we think often about AI propelling robotics, but now here's a case where I believe that advances in robotics are going to propel AI. So the AI, if given a body, can go out in the world and experience it firsthand and get rid of that bottleneck where humans are feeding it the data. And then the other thing, what is it going to do with that experience? Well, we need to figure out, and maybe we are starting to figure out with something like chat, where we're seeing analogical reasoning. And that's a hotly debated topic, I think, right now, and it's going to require more study. But analogical reasoning to leverage that experience in the physical world is going to be the other ingredient that's going to take us to the second singularity.
Okay. So fascinating. It's going to be incredible watching what unfolds in the next number of years, especially in this space. How should we approach the second singularity, and especially in terms of, the 6 laws of safe AI and, defensive AI strategies? What should our approach be to this?
Well, we've all heard luminaries like Musk and Hawking talk about the dangers to humanity of AI, and I agree that there will be those dangers. Now, interestingly, Musk went on to say that he thought we might need to take a pause and stop doing AI research, as well as having laws to regulate it. So I was a little surprised that somebody this brilliant would say that, because who really believes that this is going to work, right? Take a look at cybersecurity, for instance. You could make all the laws you want. It's not going to help at all. So I think that we can't really depend on that. I'm not saying that we shouldn't have any laws, but our expectations should be limited in terms of what we expect to come out of that. But there's a couple of things that we can do, two areas. One addresses standards and what I call laws of safe AI for well-intentioned developers. And then you're going to have not so well-intentioned developers who either accidentally or intentionally create dangerous AI. That I guarantee this is going to happen. And then how do you deal with that?
Okay.
So as for the first one, I go back to Asimov and his 3 laws of robotics. So one of the amazing things about Asimov's work is that he came up with this before there was even the first electronic computer. And
Wow.
the basic and it was in his science fiction, which makes it even more interesting. But the idea here is that in the 3 laws is that robots should not do any harm to a human, to just boil it down to the basic idea of it. And you might call that a safety objective function. So first of all, defining an objective function. An objective function is simply the objective of the AI. What's it trying to do? And this is akin to human emotions. We think of human emotions as something computers will never have. And in a lot of science fiction, you see AI, robots, so forth, as lacking emotion. That's kind of one of their caricatures. But really, what is emotion? Emotion is just the thing that motivates you, right? And maybe humans express it in a unique way at the moment. But intelligence always has an objective. And so a safety objective function is something like one of Asimov's laws. It's a special kind of objective function which ensures that the AI will not be dangerous to humans. And so originally in my book on data management, I started thinking about this idea of safety objective functions and had just a couple. But since then, in preparing for AI4, which is a conference out in Las Vegas in 2023, I realized that there needs to be more than just those 2.
Okay.
So the first 2 deal with just the idea of having objective safety functions. And so the first one is that you have to have at least one safety objective function. And the second law would be that the safety objective functions override any other objective function. Because, of course, they're not all going to be safety objective functions. They're going to be the main purpose of the thing, that it should walk, it should talk, it should be able to see, whatever. And so that establishes a good foundation. But then what about evolution? Once you establish these objective functions, you want to make sure that the thing doesn't evolve in a way so that it loses those safety objective functions. So you have two laws which are designed to ensure that evolution of the AI does not perturb or eliminate those safety objective functions.
Okay.
So the first of those is that whereas learning is a very important part of artificial intelligence, we cannot allow learning or any kind of adaptation to occur in the safety objective functions. Anything else can be subject to learning, but it cannot there. And then if you look at competition among species, you see that biological evolution is really driven by the objective function of producing the maximum number of copies of the genome. Right? So that's just by definition, that's just the way that it works. So we can't allow that in the case of AI, because once we have that sort of thing as an objective function, then the system may start competing with other entities, such as humans. And also in that regard, we're going to see AI and robots creating other AIs. And when they do, those new AIs could form a kind of evolution, right? Because each AI can create a new AI which is slightly different.
Mm-hmm.
And so when it does create a new AI, it has to pass on its safety objective functions to it.
Okay.
So then the last two are in their own categories. So you have human override, which basically goes back to Asimov's law number 2, which says a human can override any action of an AI. And then finally, you have something which is quite different. It doesn't have anything to do with intent like the first 4, and that is in terms of competence. So we know in the case of humans, if someone's doing something that they're not competent to do, it could potentially be dangerous, right? So we don't want AI to be doing anything that it cannot reliably execute. And so there you have the 6 laws of AI, which takes care of half of the problem of dangerous AI.
Okay. So fascinating. I really think this is something important to talk about and to look at, though, because of course, as we're coming into all of this new development in AI coming out, we really focusing on the safety is really important. Something I'd love to ask you about is, what do you predict for the future of humanity post the second singularity, when that, inevitably or eventually comes?
Well, we tend to think of ourselves as being permanent somehow, as long as we don't kill ourselves off with a nuclear war or something like that. But if you look at biology and species, they're always changing, and no species is permanent just because of evolution. So from our most recent ancestors, and we don't completely understand or have found all the fossils of our ancestors and characterize those, but approximately 500,000 years it took from our most recent ancestor to evolve into Homo sapien. So at some point, Homo sapiens will evolve into something else. But I think before that happened, and I should talk a little bit about like the 2 kinds of evolution, right? So there's evolution, which is driven by selective pressures, and then there's just drift. So right now, humans don't have any selective pressure on them to any significant degree. And so that leaves us with drift, which is a concern, obviously, because if you're drifting randomly, then you can only expect something like intelligence to go down, which means that it's really a little bit worse than the situation of us being static and AI increasing its capabilities all the time. We may actually be going in the wrong direction. But before those hundreds of thousands, of years pass by, I think we're going to be tempted to get into genetic modification of human beings, even though there's a lot of ethical issues surrounding that and taboo and so forth. But actually, it's already been done once. There's a Chinese scientist who has genetically modified 2 sisters.
Really?
And he was then subsequently thrown in jail for 3 years, or at least sentenced for 3 years. I'm not sure if he's served the whole thing. So it sounds improbable, but given the fact that it's already happened, and I think I think we will get to a point where it's just too tempting to not do it. So I think that is going to be the major change in human intelligence.
Okay, talk to me a little bit about that, because that's such a fascinating concept. And I know, ethical and, there's all sorts of issues there. But what does that mean, genetically modify a human? Is that try to make them stronger and taller? You just pick different traits that you'd like to enhance? What does that look like?
Well, this first experiment, he had to choose something, right? And so he chose resistance to AIDS. But I don't think that's really what he was interested in. I think he was really interested in just producing the first GMO person. And there may have been other experiments out there that have not been published or that have been done more secretly. But it could be a lot of things. And this is where I think people will get over the taboo. And I'm not advocating GMO humans. I'm not speaking against it. I'm just making a prediction of what's going to happen.
Okay. Yeah.
So it could be any of the things that you're talking about. It could be that parents want children that are better looking, that are more athletic, that are smarter. Obviously, that's the big one for this discussion. More immune to diseases. It's hard to argue ethically against that, right? Now, once you break that taboo, then you go on to the others. But the problems that this is facing are twofold. One is, and this is why I think this researcher was punished, was because the technology is not sufficiently mature to be safe. In other words, you could produce people who are deformed in some tragic way by doing it. And then I think the other problem, which hasn't been talked much about, would be the whimsical nature of creatures that humans create. So if you think of selective breeding in dogs, you create all kinds of weird things that people want to take to a dog show, right? I want it tiny and have a face that looks strange or whatever.
Yeah.
It has to have short legs. So people will probably start doing strange things, especially when you think about athletics. What kind of humans will they create for that? I'm a little bit concerned about what would happen.
The athletics one, very concerning. It's like, I want my son to be a basketball player. I'm going to make his legs huge.
Yeah, he's going to be 10 feet tall, right?
Right. Hey, so something that you said that was interesting was that, disease is less controversial, right? Like it would be hard to argue that like, if I could, genetically engineer a human to not get diseases, they don't need to take vaccines. It's just like kind of baked in. And that's what the scientist, I think, inevitably was doing that got in trouble for this. Is this like at the embryo phase? Like what like when does this genetically modified human start?
Well, just like any other GMO, they're manipulating the DNA of the at the very earliest stages.
Okay. So fascinating. Mark, it's crazy to hear your perspective on this because I feel like I get a much different perspective from you than I've heard from other people. So it's been absolutely amazing to have you on the podcast today to discuss this. I'll have to get you back sometime to go deeper into some of your concepts and things you're seeing as things continue to progress and evolve. If people are interested in getting in contact with you or, finding your book, where's a good place for them to do that?
Well, people can find me on LinkedIn. And if they're interested in the book, Next Generation Data Management, they can find it on Amazon.
Okay. I will leave a link in the show notes for the listener. If you want to find his book, I'll leave a link to that in the show notes so you can get it there. Highly recommend it. Mark Brady is, incredibly on the forefront of what's going on right now. Again, Mark, thank you so much for coming on. To the listener, thank you so much for tuning into the AI Chat podcast. Make sure to rate us. Yeah, and make sure to the listener to rate us wherever you get your podcasts and have a wonderful rest of your day.
All right.